Okay, for people joining this live stream, we are talking about a particular feature of Wolfram language that is a little bit subtle, but it is atomicity and thread safety. So let's see, who is leading this? Is it Roman?
Yes, I'm here.
Okay.
Yes, so the first is really what we need to build upon, and that is ensuring that rename file and create file are atomic, so that there's never any partial stuff lying around, or that if two processes try to rename a file to the same target and override target is false, then only one of them should succeed.
So let me understand something. Unix shells with move and things like that, do they have this safety or not?
The basic move operation is atomic. But let's say if you create output, then if another process creates the same output file, then the two of you will overwrite each other's file. So it's not, I mean, it can be done, but not every operation is automatically atomic. But the underlying operations, rename file and create file, can be made atomic. Now, we didn't do that because 30 years ago, nobody even knew what atomicity was, right? Because all this multi-threading and so is fairly new. And so our existing code is not atomic. And apparently, and it turns out it's not trivial to do so, because some distributions that we still support it's not clear whether they support the necessary operations. I mean, Konstantin is working on that, and don't know whether there's any news on.
So what distributions? These are Linux distributions or what?
Yes, I think the main one is Red Hat 7, Konstantin, right?
So I'm pretty sure that the kernel does. I mean, you won't have the library support, but if you make the raw syscall.
Yes, you can use the syscall, yes. Yeah. So I'm fairly confident that the ones that are important because they are LTS versions can be made to can be supported here.
So you're on this, and basically it's just going to be that things like rename file become atomic.
Yes, that's the main. There's no user visible change.
And so what happens if two processes both try and rename a file, and the second one there does what?
It will get an error. I mean, it will just say the file already exists. We have this option, right? I mean, there are always two versions of these.
Rename file doesn't have a file already exists. Create file.
Yes. No, both have.
Oh, you mean rename to that destination?
Yes.
I see.
So override target, whether it's true or false. So we have 4 cases, right? And whoever loses that battle will get an error message, and then we track, we handle that error. So that's how it is done.
What do you mean by handle? You mean the code? The user code handles the error?
Yes, I mean the rename file or create file will return an error, and it's then up to you to do the right thing. And yes. For example, if you want to use it for synchronization, then you set the override target to false, so that only one wins. But if you want atomicity in output, you set rename file to true, so both of them succeed. But there will never be a mix-up of the two files. The result will always be one of the two that try to write it.
Well, overwrite target is true means the later one overwrites. Is that right?
Yes. But that's, I mean,
but it'll never get corrupted. It'll just be.
Yes, I mean, it has one of them wins at the moment. Both may win, right? And so they will. So you have seen your fair share of these error messages with garbled local objects or garbled files. That's the result of non-atomicity of these operations.
Okay, so just to understand, overwrite target is true means last one wins.
Yes.
Overwrite target is false means first one wins.
Yes.
Or 0th one wins, or if it was already there for some other reason.
Yes, I mean that would be then perhaps lead to a deadlock, and then we need to treat this in some other way. But
what would lead to a deadlock?
Well, I mean, if you use a log file for synchronization, then you would use create file with override target false, right? So the first one to establish the log file will win, and it's then that process's responsibility to remove it at the end. So if that process dies or takes too long, then all the other ones would not be able to proceed.
If there is an idiom for lock files, why don't we just provide that as a top-level mechanism?
Yeah, I mean, that's
have a function set lock remove lock.
Yes, I mean that's further down this. That's also on this agenda. I mean, we are now just talking about how to implement these.
Okay, but that's fine, because I don't think the fact that you use a file as a lock is a hack. I mean, what you want is something which is a top-level locking mechanism which has timeouts and all kinds of things, right?
Yeah, but I mean, you have to decide. I mean, what is it you want to lock? If you want to lock output, then you need to use a lock file in the same file system as your output. If you want to lock something that is in a parallel computation, then you can use a kernel, a normal variable as a lock. And if you want to have some worldwide synchronization, then you would use a cloud object as a lock. So
I understand, but so let's have a mechanism, just like initialization, for this locking and synchronization that can pick its, domain. Okay, let's keep going.
Yeah,
I think I understand.
We'll talk about this later. Yes.
Okay, fine. All right. So this particular thing, I don't see a problem with. You're implementing it.
Yes.
Be happy.
And on top of that, I've redesigned local objects so that there are always all local object operations will be atomic automatically. And that will already get rid of all these errors that you see. It's still the case that, say, you do a resource function in a parallel computation, you would still download 20 copies and create the same cache 20 times, but one of them will win and there will not be any user visible damage done.
Okay, so hold on a second. The thread safety means...
Yeah, thread safety here would mean that if you try to establish a cache for your resource function, then there's obviously only one process that should create that cache, and the other ones should just wait until the cache is there if they see that somebody's already working on it. So that would be the synchronization, synchronization of thread safety. That's what I mean by that. So atomicity guarantees that there will never be any bad output, and thread safety would mean that there's only one of them that actually does the work, and the other ones wait until that one is finished.
Right. So, for example, in parallel computation on multiple machines, I have this hacky code that goes and installs a packlet only on one of the kernels that is on any given machine.
Yes, and now I don't know how well resource function caching is already trying to be thread safe, but with the new mechanisms we are talking about here, it will become very easy to do so. Because you would simply obtain a lock with a timeout, and then you see when the first one will then win, and if it manages to write the cache in a reasonable amount of time, then the other ones could just then use that cache.
So the other ones have to block if
yes.
they're trying to use it, right? Okay, so hold on, let me just understand that. So we've got a family of functions. We've got the resource functions which cache. We've got a bunch of the data functions which cache. I mean,
anything by the packlet manager. I mean, it's not caching, but you might auto update and then need to rebuild the packlet data.
Right. So let's see. So who is the project Ben? Ben is kind of the guru of caching for data functions, right? Is anybody here aware of that?
Ben who?
Emerson.
Yeah.
I'm aware of that.
Okay, so the point would be that every piece of caching that he deals with needs to know about this, because obviously we need a mechanism to make sure that those caches, I don't even know what's happening with those caches right now, whether those caches are atomic, whether they're thread safe, what the story is. Do you understand my point?
Yeah, I mean, I think one of the results of this work will be that we should systematically go through everything that potentially needs thread safety to work properly, and that is all our download data from the server, packlets, data.
Right, but I'm saying that Ben has been inventorying all of our caches.
Oh, I see. Okay, so that would be the next thing to do is to
talk
interface with
right.
Yes. Okay. Very good.
Now let's talk about other kinds of random stuff that people do. I mean, here's a weird. Well, I don't even know if this. I mean, just all kinds of external operations like creating a short URL, or I think cloud expression is being set up to be atomic from the new version is atomic from the get-go. Is that correct, guys?
Yes. Yes.
Okay. Todd, are you aware of other places where atomicity is an issue?
Not surrounding files, or
Yeah.
I think, well, cloud objects.
Mm-hmm. Okay, so I think we understand this point. Now, do you have a solution for this point?
Yeah, I mean, if you do something like this, then you either need to do your own locking, and that will be the critical section that we'll talk about in a minute, or you could rewrite your code to use atomic operations. Now, that is also mentioned further down because it's part of the critical section, that all update functions with local symbols will be thread safe in the future.
What is local symbol? Local symbol is something stored in the local object store.
Yes.
Okay.
So another area which we could think about is our general output functions like put, export, save.
Mm-hmm.
I mean, they are all suffering from that problem that when the operation starts, it creates that output file, and then it takes some finite time to finish.
Yeah, that's disastrous.
And everybody else sees partial output. Now, the way I solved it for local objects is that I always write the output to a unique temporary file. For that, I need the atomic creation of files. Then when I'm done, I do an atomic rename to the final output with override target 2. And so the result will be exactly the same, but there will never be a partial output visible.
Right, but that's unfortunately undesirable because if you're doing a put to a file, you often want to see it incrementally build up.
I'll put append, but yes.
Right.
Yes,
so,
right. And anytime you open a file and periodically write to it, then that's precisely the case where you do want the partial output.
Well, you want partial output, but the put append, it opens, outputs, closes, and that should be atomic. The next time you do an open output, whatever, the idea, okay, so there's different cases. You've opened a file and you're incrementally writing using write, for example.
Yep.
That shouldn't be atomic, as you're doing a low-level operation. Yeah, you're doing a low-level operation. You know what you're doing. If you get it wrong, you get it wrong. But all these things like put append perfectly well can be atomic. That is, the new lump that they put in, the order in which the lumps go in may be undefined, but each lump should be atomic.
Right. In the case where you're writing to a file that is not already open, because put append will perfectly happily write to a file you've already manually opened and set options on, in which case it doesn't close it afterwards. So now you're in the general write.
Okay, wait a minute. Wait. Let me understand that. It doesn't close it after the put append is finished.
If it was already open.
Yeah, I mean, I remember that design decision from like 30 years ago. Why did we do it that way?
Because I guess the assumption is that if you've manually opened the file, you may have set some options on it. Otherwise, why did you open it first? And so,
Are we sure that isn't from a time when there was some different economics of file openings and things like that? Well, whatever.
Well, opening and closing is still the most expensive part of file operations. So.
Okay. Nothing changes, but
yeah, I think we have always had that case that either you open the file, do some operations, and then you decide when you close it, or you let these functions open and close it for you. And we might well think about having that second case be atomic. I don't know. I mean, Ita has mentioned perhaps there are more cases where we don't want atomicity, and we should leave it to the user just to use that those functions that we now have to. Maybe we could have a helper function for atomic of put or atomic of export or something.
Okay, I've got a comment here. So let's say export, for example. I can imagine a case. Can I imagine a case where I incrementally watch a file being exported? Is that a thing, or is that never going to work? I don't think it
depends
ever
on the
works.
format. Some formats yes, some formats no. But it's certainly, like for example, it's not exactly parallel, but if you think about rsync, then rsync will oftentimes, write to a temporary file so it can monitor the progress, but then it will only put it at its final name when the copy has finished from the remote location.
Yeah, okay. Well, that's a reasonable thing.
I mean, if you want that, then maybe it would be reasonable to expect or to require that you actually explicitly open the file, and then you do whatever you like, and then it will stay open until you close it. So that might be a good way to distinguish the two cases.
Well,
I mean, if you don't open the file before you start the export, then the assumption is that you don't want to see the partial result, and it will do it atomically. And if you do want to see the partial result, then you should open the file, and then you do one or two.
I'm not sure
exports.
anybody will understand that. I mean, we could have an option to export that says whether to,
No, you would do it before you call export. I mean, you say
because your point is that otherwise it will necessarily, it doesn't need to be gobblable, because export knows it's writing the file. There's two different things. One is export knows I'm writing this file, but I'm not finished yet. But I'm going to write it in lumps. But nothing else can get in the way and say, well, actually, no, I'm going to write to that file instead.
I'm not sure that is possible and even necessary, because this seems a very contrived case. I mean,
well, no. The case that I'm talking about, let me give you an example, okay?
Well,
so I write out gigabyte-sized data files, okay? And I don't mind the fact that I can see that file coming in. I quite like that, rather than waiting and like, oh my gosh, kind of, white knuckle time. Is it actually going to write it, or is it going to fail? Do you know what I'm saying? And you don't know until it's all there.
Yes. Okay, I see that. Yes. Now, which case? I mean, obviously, we cannot have both ways be automatic, being atomic and being incremental. So one or the other way, you would have to do something to make this happen.
Yes, I understand. I mean, it could be that. I would tend to think the case of incremental delivery is the less common case. And I could live without it, honestly. I think it's a case where very big files. I mean, if it's a small file, you just don't care.
I mean, you could still have it. You just open the file, and then you call export with the open file.
Nobody's ever going to do that. I don't think
it's a matter of documentation, but
yeah. Look, I somewhat favor an option that allows for incremental writing, but I mean, the thing I would like best is if it's really huge, like more than 100 megabytes, for example, then I would like to see it come in incrementally. Otherwise, one lump is fine. It's like block size. You never see a file come in something smaller than its block size. And that's fine. Making sense?
Yeah, I mean, you might not know how big it will turn out in the beginning. And it seems to me that these cases are sufficiently rare that we don't have to build too much stuff.
But look, what happens if you've got a temporary file? You're writing stuff into a temporary file. The temporary file is 100 megabytes in size. Okay, you flush that into its final location. And you do that every time it reaches 100 megabytes in size. You flush it into its final location.
Yes. Would you expect that to be some automatic, or would you be prepared for this special case to actually do some programming to make that work?
No, I'm not prepared to do any programming. Why can't it be automatic? It's not going to be an efficiency hit. A 100 megabyte file is just not written fast enough for this to be an efficiency hit.
I don't see how this can work atomically, right? Because either you're copying it or, right, right, because the way we can implement this atomically is, right, we write it not to its final location, and then when it's done, we atomically move it into its location.
I know, that's what I'm suggesting doing here, but I'm
But
suggesting...
if you're saying 100 at a time, how do you do it 100 at a time short of, copying it each time you've reached 100 megabytes, in which case it's no longer atomic? Or you're doing quadratic complexity in
Yeah, I get what you're saying.
block size.
Okay, if it's a newly created file, well, it's probably more important that it be atomic than that it be incremental. So provisionally, I'm backing off my desire for incrementality in that case.
Okay, so we could consider making our main output functions atomic if they do not operate on an already open file, in which case we shouldn't do anything. We cannot do anything.
What I'm suggesting. Yes.
Okay, I think that makes sense. Yes. I mean, this is what we would do. I mean, we need a helper function that just takes care of the renaming of the temporary file and so on.
What happens? Okay, so it's in /temp. So if the thing is just really...
No, it will have to go into the same directory as the final output. I mean, so that's what just the next topic. We need some improvements to our temporary file creation because that's really not up to speed currently.
Well, I mean, the main issue is if things crash, leaving CRUD around. What clears out CRUD if things crashed?
Yeah, I mean, there are two. One is to create it in a temporary directory, but then there may not be an atomic way to move it to its final destination if that's on a different file system, which it always will be. And so usually, I mean, there is a way to do it. I mean, you create the file and then you unlink it. And so if your process crashed, then the operating system will take care of that file. So it's actually something I didn't think about, but we should consider that unlinking trick for these temporary files. That's a good point.
Well, so wait a minute. So you're saying we could use a temp directory, and then we could use /temp.
We can't, because then we cannot atomically move it to its destination, and it will be inefficient because you copy the data twice.
Okay, fine. So you're saying it should be in the with all the tilde named
same directory as the final output. And so the easiest to use would be if we had a function that, given a file name, would derive a unique temporary
right. But
file.
By the way, you've also just solved the incremental output problem, because if you want to know what's happening incrementally, you just look at its temp file.
Yes.
So that's fine.
Except if it's unlinked, then you don't see it. But
so we unlinked from the get-go.
Unlinked. I'm not sure what you mean in this case.
Yes, I mean, that's so I create a temp file and write to a temp file. But the question is, if the process dies, then the temp file will stay in the file system. And so what you usually do, you open the file and you unlink it. So it's no longer referenced in the directory, but you still can use it as long as your process is
that's a
alive.
Unix file system.
Yes.
Does that work on Windows?
Yeah, I doubt that would work on
I
Windows.
don't think so.
It's also very weird because it means that you'll be using, let's say that's a 100 gigabyte file. You're like, oh, there's a weird mistake. I don't even know. I didn't even know that was a thing. How do I even know there's a 100 gigabyte file there?
Well, I mean, you can if you look at the free space in your file system, you will see that correctly. I mean, for example, Mac OS does something similar. I mean, you can have your disk apparently half empty, and it still gobbles up all the rest for some backups and whatnot. Sometimes it's quite hard.
Well, it's
actually.
that's that's using the VM and the virtual memory and snapshots, which is not exactly the same thing. But right. So you're saying basically you unlink it and then you relink it prior to renaming it, or
You don't need, no. As long as you have it open, you can still
It's
use
a ref
it.
count. It's
just
a ref count thing.
It just doesn't. There's no entry in the directory.
Right.
But there's
the
nothing
last
wrong
reference from the open file goes away. The file gets deleted. That's how it works. It is a ref count.
Okay. And do all Unix file systems actually support this? I mean, I was not aware of this particular mode of operandi.
It's a very early feature of Unix file system.
What's that?
This feature existed for a long time, so I presume
it's like things that exist in us that already existed, 2 billion years ago in the history of life.
Right. Well, yes, unless somebody decided, well, I'm going
Take
to
it
write
out.
a system which doesn't do this. But
it's a very useful feature, so I thought that's what you took.
All right, okay, but so that's probably part of the option that all these functions should have about where to put their temporary files. Something about the strategy for the temporary files, because you might actually want in that model, you don't get to see the temporary file build up, but there are cases in which you would like to see the temporary file build up, and in which you're perfectly happy. You've got a bunch of random tilde crud left in your directory. You'll just delete it. Am I making sense?
Yes, that could be an option of the new create temporary function.
Yes, I agree.
Okay. Yes.
Okay. So
that's
then,
a good point.
Okay. So now what's all this stuff?
Okay. So that creating temporary files. So to make this work, what we just talked about, it needs to be easier to make temporary files in some given directory. Mm-hmm. And actually, from all the suggestions down, that it's only the last one that I'm now suggest, because that was just my thinking about, and I finally then found an easier way to do it. So now we had a create temporary file.
What suggestion should I be looking at?
The last red point there, or new rather old function create temporary at a little bit further down, right there. Yes, that's the new one. So all you need is, given a file, create the temporary file in the same directory,
right?
With some option, make it visible, invisible, and every operating system has its way of hiding files, like the dot files in Unix, which we should use. And I think that would be a very useful function. Now the question is, can we call it create temporary? That is something we do some time ago. Now the old one doesn't have arguments, and the new one would have an argument, so it would be possible to reuse that create file.
Well, the create temporary without an argument would presumably create something in the temp directory.
Yes, like but we deprecated that function. If you go back to the
I know. It's now in create file, it says.
Yes, a create file shouldn't do both of these. It's rather strange. And so I would suggest to revive the old create temporary.
Create temporary does
with an argument.
Yep, I agree.
Just for the create a file or directory.
Yes.
Not a good name.
I'm sorry, what?
It doesn't suggest whether you create a temporary file or temporary directory, so it's not a good name.
Well, maybe
create temporary file, maybe.
File. Why not?
Create temporary
file, yeah, okay.
Okay.
Why cannot we have an option for create file to indicate the location?
Yeah, but it's kind of strange, because you cannot give a name template for create file.
I agree. Create temporary file seems the right thing.
Yes.
By default, does it make it give a new one each time?
Let me argue the alternative here. Why isn't this create file option make temporary goes to true or something like that, which does whatever, right? That takes that as a template and creates the associated canonical temporary file.
Let's not put it into create file. It's really a different operation. Create file is something people do for whatever reason, but temporary files are something weird, ephemeral, unlinked, funky, heuristic, whatever. And this would be a file name, and it would create a temporary file that is a unique temporary file associated with that file name.
Right. It has a UUID in it or something.
Or whatever
No,
it is to make it
yes, I
unique.
mean,
Yeah.
it
Probably
only
wouldn't
needs a
put
few
it.
characters, right?
Yeah, it
Because
probably
the
wouldn't
number of
be.
files you can create is rather limited. So, I mean,
Right.
that we already do that with our create temporary. Right? We just use these visible names M000 whatever, and
I don't know
we
what the
need
M
something
comes
better.
from. Yes. I mean, I think we can redo create file. I think we should use something which is more like a UUID and create whatever. Create file. This is an ugly temporary file name.
Well, that's create temporary. That's not create file.
I know, but doesn't create file do the same thing?
I mean, the main
It does the
problem
same thing. Yep.
the main problem with create temporary is that we do not create these temporary files in a subdirectory of temp, but in the main temp directory. So they
Create files
The
still
hell
uses
is
TM
this?
prefix. It does the same thing.
What
Well,
is
you-
this?
That is the value of $temporary directory because it's per user on Mac
So
OS.
not the M prefix.
I know, which
Yeah.
is the wrong prefix now. And I think we should be a little bit more, possibly we should even, reveal ourselves in these names. Wolfram dash some UUID.
we should use a subdirectory for our own temporary files.
That's-
Okay, fine.
Masslink already does that. That's the one case that doesn't clutter your temp directory.
Okay, so what should the name of the top level directory in which our temp files? Wolfram temporary files or something? I mean,
It would be
why don't-
more
why don't just-
powerful to just call it Wolfram, right? It's in the temporary directory, so just
fine. Okay, that's fine.
No, that would help reduce the clutter.
And then
So it can be shared by Mathematica and desktop and
yes.
player.
Yeah, I mean, yes, I mean, these files do not have anything valuable to them, right? So the only thing that matters is that you create a new one every time you use that function.
Would it be a UUID or would it be SQL? I think it should be a UUID. That's much safer. You don't have to. There's no race conditions on UUIDs.
Well, they're just so ugly, so long. I mean,
yeah, but how often
already
do you
does a
type
UU.
them in?
But listen, if you end up with a collision of two files, is the file creation atomic? I guess it is.
yes, it will be, and so it just iterates until it finds a unique name, and that iteration chain is very short if you start with a 6-digit random number, right?
Fine.
It
All right.
could
Okay.
use
So then
some
it'll be a minimal UUID basically.
We could
you-
use some shorter prefix like MD5 or something.
I mean, it doesn't need to be universally unique. It needs to be unique per file system. And
I know
that's
that.
enough.
I realize that. I realize that. I'm just saying it should look like a UUID because it's
Okay.
less confusing, and I think it should use the same, characters probably as in a UUID. Maybe it could use all. I don't know. Whatever this is. This is using all
No,
things.
that's macOS. The
Okay, so
part- so
I get it. I understand. I'm
Okay.
just saying, why don't we just use, to keep these names short, why don't we use 36 characters and we just increment through them?
Yeah.
I don't know whether we want to, do we want to start with 00000 or do we want to,
you
do we
should
want to
start
make
with
it?
a random value. Then there's less collisions.
It's just a hash, whatever it generates.
Okay, fine.
It's
All right.
simple-
Okay. So
simple.
that's agreed what that is. Okay. So then create temporary file. We'll create a file using, and then it could have a second argument, which is the style of file, so to speak. The style of hiding, so to speak.
Yes.
Like that could say, for example, dot file.
Well, I'm not sure that makes sense, right? On Unix, it should be a dot file. On Windows, it should be a
Alright,
file
okay.
with a hidden attribute.
Yeah. The default should be automatic. I mean,
All right, fine.
I think more important as some other aspect like that the temporary file would have the same extension as the base file so that we don't run into problems with file types. And then you would have an option.
Should it?
to-
Should it? I don't think it necessarily should, because if it isn't, I don't think most programs do that, because you shouldn't be able to open it with an opener of something until it's finished.
Mhm.
I
Since
would not give-
But if you're going to be exporting to it, export will need to know what the format is.
No, but I'm saying the only thing, this file is just holding a bag of bits until it's ready to be moved into its final location.
Yes, but I mean, what I think ITA means is if you use a file name in export, export will look at the file name and decide what to do.
I understand, but it's never going to see this file name. This is internal.
Yes, it will, because
yes, it will. If
export
we're
will,
going to make it atomic, it will see it.
Export will be invoked on the temp file, not on the final output.
Okay, fine, but you can feed export. It's explicit.
Yeah, but then it doesn't behave the same way, or it's not guaranteed to behave the same way.
It is not a good idea to have a file which is an incomplete file that's supposed to be, I don't know, an XLS file or something, and it isn't. Have a .xls, and most programs do not do this.
Okay.
I don't think that's true.
Well, I've been in many situations where things crashed and I had to go try and find their temp files. Okay. And essentially always the temp files did not have the file extension.
yeah, I see that. Mhm.
I think it's common to have whatever dot part as the extension.
They usually add some maybe .xls, .tmp or something like that.
Well,
So
that's
It's
possible.
never
Right,
the
something
proper
like that.
Yes, that's possible.
But
Yes.
I don't think that style of hiding makes any sense because it's already a temporary directory and you don't need to hide anything there.
It's not a temporary directory. It's not. It's in the same directory as the final file is going to be assembled. It is not a temporary directory. That's a different branch we're talking about.
Okay.
Yes.
Okay.
I think
So-
we have it under control now.
So there's a comment here from on our live stream about temp files can have issues on network drives and synchronization through Dropbox, OneDrive, etc. So consider defaulting to the user's local temp directory. Well, if you're defaulting to the directory that the file is going into, oh, I see. There's a question of create temporary file. What is its default directory that it uses? Is it
Well-
a user-specific temp directory, or is it a system temp directory?
It has to be the current working directory.
No.
Yes, if
No,
it's going to, if it's creating it in the same directory as file name would be
No. You missed a point here. There's three cases. There's three cases here. Case number one, you are creating a file in a known destination directory. Then the temp file has to be created in that same known destination directory for ease of moving, whatever it is there. Okay, that's thing number one. Thing number two, case number two, is you know nothing. You're just creating a temporary file somewhere, and there is no definition of where it's supposed to go. You just want to hide it away somewhere. You're going to use it for some internal purpose. You do not want that in your home directory. That would be horrible.
I don't see how create temporary file can have different semantics from create file.
Yeah, I think we are not talking about create file which defaults to the temporary directory. Here, the question is if the file name you give as the target.
Then it's very clear that it's that file name.
No, Stephen, the file name could be absolute, and then it's clear it's the same directory.
I understand. If the file name is relative, then it's relative to your current
must
directory.
be relative to the same directory as you create.
I completely agree. Okay,
Yes.
so the case that we have not covered is create temporary file, open bracket, close bracket. Where does that go?
Temp directory.
What's that?
Temp directory.
That's what I think. Yes.
But I don't understand what this is. I get. Well, I mean, I suppose right, because if create temporary file is supposed to be creating some, temporarified name of file, which
No, it's not. It's create temporary file of a file name, create something which is a temporary decorator name of that file. Okay,
Yes.
Create temporary file of no arguments is doing the same thing that the current create file is doing. Okay, but the question is that
and how is it different from that create file?
it's not necessarily. Okay, it's not. It's repeating that functionality. Okay, but
Another thing that would be useful. Sorry, go ahead.
No. But the point is, which I think our live stream person is commenting on, is that it may not be smart to try and create a temporary file in a central /temp directory. It may be better to have a hidden area in the user's home directory, which we know the user can get to, right? That has those things in it. And that, for example, I don't know if you're using, let's say, Dropbox, okay? And I've got a bunch of directories that are put on Dropbox. Do I want the temporary file to be in my Dropbox directories or not? Do I want the temporary file to be synced over with Dropbox or not?
Well, do you want to move it further? Do you want to rename it? You will have to transfer it if you do anything. So I think for what we are looking at here, the create temporary file with a file name argument will always be the same directory. And it should work with anything that has locking semantics, and that is most network file systems.
Your unlinking trick will presumably cause it not to be synced by Dropbox, correct? Dropbox will be syncing based on things that
I'm not sure. Dropbox probably doesn't support that trick. I don't know. I mean, it's
no, but by support.
Dropbox,
just a second.
Dropbox just scans its directory periodically and copies things, to the server or from the server.
Fine, which is good, because we don't want it copying a partially constructed temporary file that was unlinked.
Right, but is this thing unlinked, right? I mean, how is this thing unlinked? So
this one is not unlinked. This is, okay, our internal, well, maybe we need an option to this. How do you refer to an unlinked file?
Well, you have to have it open before you unlink it. So you open it, and then you unlink it, and then you can still use it like normal.
Temporary file is
the file pointer is pointing to it.
Is create temporary file then returning an output stream object?
No, it would.
No, you create a file descriptor and you hold the file.
Okay, but hold on. There's a different operation.
No.
Okay, wait a second. Different operation is open a file and unlink that file. Okay, so we're doing an open write or something like that, and then we're saying some kind of file unlink. And then the open write, the file descriptor, the file pointer is still valid, pointing to that file, which is no longer listed in the directory because it has been unlinked. Is that correct?
Yes. I mean, in fact, I wonder whether it would already work now. I mean, if you open a file and then you use a delete file, whether it would still work or not.
Okay, well, that's a good question to answer. But I mean, that's a very, very obscure way to do it.
Yes, but I mean, I agree. I mean, it's not something we should. And I mean, you are right. I mean, we cannot say create a temporary file and unlink it, because create temporary file will not open it. It will just return its name. And it's then up to you to open it and unlink it if you so desire. We don't need to support this in this function.
Right. But okay, so create temporary file, open, close, I think should create a temporary file in some hidden directory of your home directory. Yes or no?
No.
Or should it be in a central /temp directory?
Whether it's central or not depends on the operating system. On the Mac, as you just see here, you have your own temp directory. On Unix, you typically don't have your own. So we don't have to.
Well, it depends on whether you've modified your environment variables, but by default you don't.
Or some,
I mean, it should just honor whatever setup you have.
Where they want to create temporary files. I think that's the issue. You should be able to indicate where you want to create them, and if you don't, then they are created whatever.
All right. Okay.
I mean, we have $temporary directory, and that is, I think, what we should use. I mean, we don't need to invent something new here.
Fine.
One thing that would be nice also is to be able to get the name without creating the file. If we have this default,
that's realistic. I mean, I think that
yeah. I mean, it is possible. It's just not atomic. I mean,
right.
So, by the way, I just did the experiment of of deleting an open stream, and apparently it closes it and then deletes it. So we would need to
No, yeah, so we need a separate file unlink function if we're going to do that.
I mean, if you wanted to check whether the temporary file exists for a given file.
What?
If you wanted to check whether it exists, whether the temporary file exists, you want to see, did my operation crash? And there's still some hanging file here. You want something that will, tell you where the temporary file would be if it did exist, so you can use file exists queue on it.
Yeah, I mean, you get the name back from temporary file. That gives you the name of that file.
Okay, listen, I think we got to a resolution here. So let's move on.
Well, let me just offer the quick observation that I think it should be like unlink stream file, right? Because it's really, right, you need the open stream in order to unlink it in the way that would be useful.
Yes. What are some other operations on streams? What are they called?
I don't think it's correct to.
Well, we have the write family, the read family, and set options, I think, are the main things we have on streams at the moment.
Okay.
Maybe you could have it be an option, right?
Yeah,
so
right.
Unlinked or something.
Yes, it could be an option. For a stream, why not?
Yes.
Set stream position is stream position are sort of I think the two main operations that are specifically on streams.
I mean, stream unlink. Can you link a stream that is unlinked? Yes, you can, presumably.
Yes.
So there's basically, is there a name for this? Is this stream connected to a file in a directory or not? Right, that's the question.
Right, which, some streams never are, right? If the stream is a pipe, it's never backed by a file.
Right. Well, so the option, backing file or something for a stream, we could have such an option. And if it's none, then it's unlinked. And if it's a name, it's a name, and you can change the name if you want to. That would be my initial suggestion.
Right, although I think that would only work if it started its life as file backed. Right, I don't think you could suddenly change a pipe to be.
Is that true? I don't know. I don't know that.
You can redirect pipes at the beginning of a process. I don't know you can do that in the middle.
Okay, we can determine that. Okay, we need to move on. Synchronization and locking.
Okay, so this is now what we can do once we have all the homework done with the atomic operations. So this handles thread safety. So you want to have a block of code and guarantee by agreement that you're the only one working on that block of code.
I have to say, I would much prefer to use a term like thread safe than critical section. Critical section is just like, it seems like it might be a piece of an airplane, or it might be, anything.
Mm-hmm. I mean, we already have it for parallel computing. And so what I'm proposing here is to extend that notion so that the lock object can now be a file or a local object, and in the future, perhaps even a cloud object.
Okay, but I think we should change the name critical section. I'm telling you, it tells me nothing, right? I mean, for the typical user who isn't steeped in distributed computing lingo, it tells you absolutely nothing. What is it? It's thread safe. Is that right?
But it's not necessarily threads.
It's not.
Multiple processes.
Right. In fact, it's not threads
many
at
things
all.
make things not thread safe. This is just one of them.
Okay, but this is, this is lock evaluate or something. Locked evaluate.
Yeah, that's good.
I mean, it could be something in the block family. I'm not sure exactly what, but.
Well, but a possibility would be locked evaluate. So this would be in the family of remote evaluate and, all the other evaluate things. This is a special version of evaluate that is somehow locked.
Or could we use the with? I mean, we have with cleanup and with lock.
Synchronize is another word these things can use.
Well, let's just understand exactly what it is. So the first argument of this is the locking, the thing that records the lock,
Yes.
right? So locked evaluate with, well, okay, what about with locking? And then there's the lock
Yes.
location, and there's the expo.
That makes sense. Yes. Yes.
Question
By the way,
is,
it's just a lock. If it could be a mutex, then it would be threads.
Yeah, I mean that depends on the lock location. So we have,
It's not necessarily a file.
No,
No,
I
no,
understand.
no,
We know that it could be a variable.
Could
Right?
be
The
a
locking object, lock object.
yeah.
yes.
What happens to the existing symbol arguments?
Well, these will be lock objects that are local to a parallel computation. I don't want, okay, having a new name would give me a chance to rethink that, but my current design is completely compatible. So at the moment we have 3 lock object types. We have files, we have local symbols, and we have shared variables, each for its own purpose.
Okay,
And
so you just didn't list the.
yes, because that's
variable.
already, yes, I forgot to list that because that
Forgot to
doesn't-
list what? Sorry.
the current critical section
Symbol.
which supports shared variables for parallel computation.
Right. So, there's a form of critical, the currently documented critical section is critical section of var, comma code, or var list, comma code.
I have no idea how this works. I never use this stuff. And I use parallel computation every day. So it's a bad sign. By the way, I was very happy. I used Jesse's batch job submission stuff to AWS yesterday. Worked beautifully. Very nice, actually. Anyway, in fact, I might even still have something running there. The only thing I need to know from that is a better way, which I'm afraid is not made easy by anything, to estimate how much it's going to cost to run some particular computation. Because I had no idea. I think it cost like $2, but it might have cost $200, or it might have cost more than that. I don't know.
Yeah, it's no wonder that
Well,
Amazon doesn't make it easy to find out.
Well, if you don't know the cost, doesn't that mean you're a Lisp programmer?
What?
Oh, there's an old line by it's not Bjarne, it's some C advocate that the Lisp programmer knows the value of everything and the cost of nothing.
Okay. I'm not sure I necessarily completely get that, but whatever. Okay, set shared variable. What does this do?
Well, this turns the access into a variable that is maintained on the master kernel, and every subkernel will synchronize its value. Now, this is a textbook example. If you look on the right-hand side, if you look in the expo in the critical section, then you see a read access to access and a write access. And if you do it without the critical section, then it will not be thread safe, and the parallel kernels will override each other's values. And so this part of your computation needs to be protected with a lock. And so that's what critical section does.
I don't understand. If you say with locking here,
yes,
what's very obscure to me is this variable that only appears inside that locking mechanism, right? So to me, it's like I want a one argument form of with locking.
Yes, and in fact, if you look on the left-hand side, the last part of my agenda, because we've talked about this before and I've talked that out. So in certain cases, you can actually specify the thing you want to protect as the locking argument, and the system will figure out what to do. But this is, of course, limited to things that work as local objects. So you don't get anything other than files and local objects and cloud objects. And with local objects, it will no longer be necessary because they will be thread safe.
I'm confused.
Automatic.
I'm confused. Why do I need this first argument to critical section here? In this case, in this piece of code here, I could just make a symbol because it knows I'm trying to take this critical section, not another critical section. There's no synchronization with anything outside of this. It's just, with locking this particular thing, xs equals xs plus 1 is done with locking. And
yeah, but I mean, if you have other parts of your code that work on a completely different variable, then you don't want these two to wait for each other. So critical sections.
I know.
Yes,
so it's essentially lexically scoped, and basically
there's no lexical scoping because this will happen all over the place, especially if you use files as long. Excuse me.
I know. I realize that. I realize.
Yes.
I'm saying. Look, I'm saying, if in this case we're using a variable as a lock, right? And all I want to do is to have this single critical section,
Yeah, but there are 32 of those in your 32 parallel kernels.
I understand that. But what you're saying is I've got one piece of code here that says parallel do of with locking expa. Okay, and so the idea there would be comma 10 or something. Okay, so what would be the point of that? The point of that would be that this is saying this has to have locking so that the parallel kernels can't execute these expas at the same time, which is the same thing you get with this lock here. But there's no reason to specify that lock in this case.
In this case, no. But if you go to the neat examples, then you see the dining philosophers, which are a counterexample, because there you have variables which represent those forks.
I
and the
understand
locks
completely.
are the philosophers, and so
yes, I
this
understand.
case does not work in this.
I'm well aware, right? I'm well aware. I'm saying that the simple case, right, involves no philosophers and no forks, right? The simple case is just the philosopher. Every philosopher is on their own, right? They're not. Do you understand what I'm saying? They're not.
Yes, but I mean, it's not even guaranteed that all of these. I mean, parallel evaluate is a simple case, but there's no reason these kernels couldn't run different pieces of code. And so that case where every parallel kernel does exactly the same lexical critical section is not a very common case.
Why? I mean, this is exactly what I would want if I was doing something. Look, for example, let's say I'm doing parallel map across a whole bunch of things, and I'm trying to maintain one variable that is, let's say that parallel map is testing 1 billion cases of something, right?
Mm-hmm.
And I'm accumulating successes. Right?
Yes, then you don't need all of this. You just need a shared variable, which is automatically thread safe. What you need is the XS, and you can simply say append to XS on each parallel kernel.
I know, but what about an alternative form of that code, which is more functional, where I just say with locking, append to XS something in here, where I don't have to declare this variable?
Yeah, but if it's not shared, then nobody sees your results. So,
well, but what if I was throwing it to a variable? No, that's not correct. I mean, oh, I see. You're saying that each of those things is inside the parallel kernel. But if if this expa did a thing that was global, how do I refer back to a variable that's inside the master kernel?
At the moment, you have to declare it as a shared variable. That essentially giving access to all parallel kernels of the variables in the master kernel. And I mean, there could be alternatives. I mean, I've thought about callbacks and things like that at various times. And I think now we probably have the technology for it. But I mean, another thing you could synchronize, right? Your expo could write the results to a file.
Mm-hmm.
And then you And if you use the same file, you need to lock access to that file. And so far, the only way to do it is to use that existing critical section. In the future, you will be able to use the new with lock and just specify the file as a lock.
I know, but you don't even need to specify the file. That's the point I'm making. If it's lexical, you need to specify nothing. You just need to specify the operation you're trying to do, because something provided
if you have two processes that are not connected as parallel kernels, just running completely separate, there is no notion of lexical scoping.
I understand that. I'm saying for the case where with locking is inside parallel computation, this can be done lexically. If you have two different functions and two different things, you're absolutely right. These processes cannot communicate. The whole point is in a parallel computation like this, we have a master kernel with subkernels, and so we understand how the communication works. Right? Therefore, we can do this without you having to specify where the lock is, because this lock is just some randomly named symbol that you've made up. You do not need to know that name.
Yeah, but if you, I mean, well, maybe, I mean, I need to think about whether this notion of no lock is useful and even well defined, because I mean, I'm always seeing things like you have several different types of critical sections, and so you need to sort out which is which.
No doubt, no doubt. But I'm saying the lexical version of with locking just says whatever that expr is, it is, there is locking when you execute expr. That's it. That's all it's saying.
Okay, so it would be, I mean, it would amount to some default lock variable, right?
Yes, but it isn't always the same default. It's picked differently. So if I say with locking of expr, and then I say with locking of expr2, okay, so, and then I say here, and then in the middle here, I've got a foo here, then, what that's doing is it's making those two things be locked.
Independently.
Yeah, independently.
Yes, so I mean, maybe we just need an expr hash and derive the lock name from that. I mean,
it's fine. Whatever.
Yeah, I mean, okay, I'm beginning to see what, I mean, I'm still
Look, I think
a lot more thought, but I think what we should take from this meeting is that with locking is a reasonable name, and we will support the 2-argument form.
Right. By the way, this 1-argument, 2-argument form is reminiscent of the way that confirm and close work.
Yes.
You have a lexical form with 1 argument and an explicit form with 2 arguments.
Okay. Yes.
I have yet to see anybody use the 2-argument form. Right.
So, yes. Okay. I mean, because I mean, I think whenever you have non-local flow of control, then you probably, I mean,
if it isn't lexical, it's very complicated.
Yes.
Okay. All right. So that's a suggestion there, but let's understand. So that's the main thing for critical section. Is that right? That you were discussing?
Yes. The time constraint is because that you need that to detect and to handle deadlocks. And so the idea is that
what happens when the time constraint is up?
Well, then it returns and signals gives a specific return value or timed out, and then you have to deal with it. I mean, you have to decide whether you want to break the lock because you assume that the other process has died, or whether you want to wait some more, or whether you want to return to the user with an error message. I mean, that is.
So who decides that? Where do you do that?
You need. I mean, the next you look at the return value of critical section, and then you see what happened. And every piece of code has to make up what to do. I mean, there's no unique best solution, right? I mean, for example, if you use this for creating a cache, you might decide to break the lock and just go ahead with a cache yourself.
Wait, what does the code look like outside of the thing? Can it use the confirm and close mechanism, for example, to deal with what happens if the lock is broken?
That's actually a possibility, yes. I mean, at the moment, it just either returns the result of code or it returns $timed out. So it follows the same principle as all the other ones that catch. And I mean, it's in a way some
well, actually, I mean, what happens if I say time constrained of pause of 2,1, for example, that will return $aborted.
Yes, I mean that's unfortunately not
think-
a very good thing to do. I mean, to generate an abort. I mean, here time constraint is more benign. I mean, I can detect it without
I understand,
sledgehammer.
but confirming close are looking for particular things. So, for
Yes,
example,
let me think about whether that could be made to. That would actually be. I mean, with cleanup is another possibility, because you usually have to clean up after a deadlock and so on. So let me think about
all right, okay,
possibly
what the
interplay.
code looks like around.
Yes. Okay.
that
That's
thing.
a good point. Yes.
Okay. All right. What else do we need to look at here?
Well, I think we've covered we've this thread protect. I think we now have with lock, which I think is the better, although slower, slightly lower level version. I mean, here
what is this?
Well, the idea that's the other approach. You, instead of making up the name of a lock to use, you let the system decide what kind of lock it needs. You specify which resource you want to protect. So I want to do undisturbed output to a file. And so I say protect this file and let me do my thing.
Well, but actually the word with locking could perfectly well be taken to mean the thing that's the first argument is the thing that is being protected and locked.
Which, yeah, but this is much more limited, because I mean, there are only 3 different cases for the lock object, but the code that you want to protect could do anything, right? I mean, it could.
Sure, but what's the difference between your thread protect here? Seems like its first argument is a lockable object again.
Yes, but it's not the lock file, it's the object that you manipulate in the code. So I just wanted to bring this up. I don't think this is a very good or very useful way, but it's just something that came up about a year ago when we talked about this. But I think with locking is a better way, because you really need to think about what do you want to use as a lock. You shouldn't leave it. And the case of local object isn't even necessary anymore, because they will be thread safe. And so I think.
Right, okay. Ethan on our live stream asks when the new version of Parallel Tools is coming. Didn't you just send out mail like a week ago?
Yes, in fact, the next 12.3 build should have, fingers crossed, the new Parallel Tool stuff. But of course,
Yeehaw.
I mean,
how many years is that? Okay,
6 years. I mean, I didn't work on it for 6 years, but I mean,
it's been coming for 6 years.
Yes, and I was able to. I mean, I now understand a lot more about these things, and I was able to reuse a lot of code, everything I did for these cluster kernels and so on. So I think it will be a good, and it's not finished yet, but it's a good thing to have in 12.3, and I will add more stuff to it before.
And so remote evaluate, and you're also dealing with the evaluation menu in the front end, yes?
Yes, that's the third. I mean, at the moment we have remote evaluate and parallel tools which use the same new kernel specifications, and the pièce de résistance, the final thing, will be the front end, which is more of a management task than technical, I think. But
well, no, I don't think so. I think it has UX stuff that has to be untangled.
Yes, I mean, yes, the UX stuff will be the same. It will just be the UX for specifying kernels. And the main thing is technical, because the front end has its very specific ways of dealing with these kernels. It has these extra links to the kernels, which nobody else uses for the dynamics and stuff like that. And these need a little bit of thought, especially if you go over the network with SSH or with WSDP server. But I think now it's very realistic that we can do it.
Okay, good. All right, let's see the question. Just a comment here from Valued on a live stream. What about an atomic attribute for symbols that would have this locking behavior be more declarative? I mean, that's the equivalent of set shared variable.
Yes.
But that's only relevant. Locking is only relevant when you're in a multi-threaded parallel.
Yes, I mean, normal symbols are don't need or benefit from this, because you cannot access them from anywhere else. I mean, we're talking about local symbols, and they're all automatically atomic. And of course, cloud objects would be a big another thing we need to look at. And once we have this, and so I think set shared is the answer. I mean, if you need to talk to with parallel kernels, then set shared variables are often the best way to do it, because you get the synchronization automatically.
This whole parallelism, synchronization, etc. thing, I am slowly working my way towards this grand new theory of how all this stuff should work, based on what we've learned from the physics project and ideas about reference frames and all this kind of stuff. Not ready yet. And it also relates to all these causal graphs, and because the causal graph is the story of what can affect what. And it's something, a causal graph, I mean, interestingly, what in our physics project, we have this notion of space-like separation and branch-like separation. Space-like separation, I suspect, is the analog of being inside one process, and branch-like separation is the analog of being in different processes. And I don't exactly know what the need to think about what the whole isomorphism operation that we have of branch-like separated things being merged, what that's all like about. But
I mean, that probably ties into consistency and all the difficult questions about
causal invariance, which we've studied greatly in the physics project, and which is what leads to relativity and things like that, is eventual consistency. They're the same concept.
Okay, good. Yes.
I mean, needless to say, there's nothing new ever. I mean, eventual consistency is a little bit closer to confluence than just causal invariance. Causal invariance is generalization that works for infinite time processes. But yes, that's and once you have that, you have this notion of equivalence between reference frames. Once you have eventual consistency, different reference frames that basically do things at different microscopic times, it doesn't matter because there is eventual consistency. But nevertheless, the way that you actually think about programming can be vastly different depending on what reference frame you're using. And essentially, you can be in some boosted frame where, I mean, again, I don't completely understand all these analogies yet, where I don't know. I mean, it's like you have a bunch of things you're following. Let's say you're traversing some graph or something. You can be doing depth first, breadth first, whatever else. This whole study that I just did of combinators is somewhat revealing of these kinds of issues. I'm currently in the midst, almost at the end, of studying multi-way Turing machines, which one would have thought were trivial, but they are completely not trivial. Not only are they not trivial, actually, Roman, this is a question for you or anybody else on this. I have been trying to look up the history of non-deterministic Turing machines. And so far as I can tell, they kind of gradually seeped into computer science. First, there were non-deterministic finite automata, which are, 1959 were early papers about that. And then by 1970, NP completeness was being discussed, and the idea of non-deterministic Turing machines was kind of emerged in the definition of NP completeness. But it turns out, so far as I can tell, nobody has ever looked at, people have looked a bit at small Turing machines. So far as I know, nobody has ever looked at small non-deterministic Turing machines, which I have now been looking at. And in fact, one of the surprising things is that I have pretty good evidence that the simplest universal non-deterministic Turing machine is incredibly simple. Considerably simpler than the simplest deterministic Turing machine we know as a result of that effort of mine, whenever, decade and a bit ago, is this thing which has 2 states, 3 colors. So I've been on the hunt for the simplest non-deterministic Turing machine, which I believe to be significantly simpler than that. But why is this all relevant? Well, the whole point is, which actually I have not described in the thing I'm writing right now, is the relationship of parallel computing to non-deterministic Turing machines, right? Because essentially what's happening there is, one could probably formulate a bunch of these things in terms of thread safety and so on. I mean, if I were to pull up the random pictures that I have, where are they? Where Let's see. Not very exciting, but these are non-deterministic Turing machine multi-way systems, multi-way graphs, and those are halt states. So this is one which halts, but it has many different ways to halt. So it has no causal invariance. But there are other ones I might not have pictures of here, which have oh, there's a remote batch job. Anyway, so I don't know what the significance of this is for our current purposes, but I'm slowly working towards some kind of grand unified new theory of distributed computing that makes use of ideas like causal graphs and notions from physics. So
but
I don't know
these
how
we all assume that there is communication between any two of these processes, right?
No, every branch is separate.
Okay.
Every branch is doing its own thing. The merging of branches is assumed. It is assumed that if two branches go to the same state, they will merge, which is not obviously something that is implemented in computer systems. I mean, eventual consistency is the statement that you will always get to the same place. In other words, you imagine that you follow only one branch in typical, there are multiple branches that could be followed depending on what microscopic ordering of asynchronous events occurred. But you imagine that in a particular case, only one branch is followed. The case of quantum mechanics is the case where essentially every branch is followed. And that's what, if you think about quantum Turing machines, that's what they're trying to do. And anyway, longer story, but right. Anyway, not ready yet, but I think I'm going to have a really pretty nice general theory of this. But it isn't ready, and I don't know how it's going to relate. I mean, it would be nice to think about how this theory is going to relate to what we, to being able to do. Because right now, our parallel computation is mostly, send the same thing to all these different subkernels, right?
Yes.
So the issue is, and then the subkernels. I mean, I just need to think about how this. I don't know yet. Anyway, to be continued. All right, we should wrap up here. Good. I think we made good progress here. By the way, does anybody, I'm sorry, if anybody happens to have any thoughts about the history of non-deterministic Turing machines, now's the time to tell me about them, because I'd like to. Anybody know anything about that?
No, unfortunately not.
Fair enough. Okay. Thanks a lot, everybody. Thanks to folks on the live stream. And wait a minute, somebody just sent something here. I know it had sent some messages, but this was a while ago, and I don't think there's anything to do with them now. I wish you'd said something. Okay. All right. Thanks a lot, guys.